Hi everyone, and welcome in this new episode of the Git series, the series where we try to implement Git in Scala. In this episode, we are going to continue to explore the Git index binary formats. So in the previous episode, we did a bit of an experiment here, just to see using the codec library if we could read Git index file. You can see here that we are loading it from this same repository, and we saw that we could see the headers, read the headers, and read some of the property of the first entry. That was a good first throw at it. I think now we need to structure a bit and start putting a test around it. So what I'm thinking is, so the challenge here is that I'm not sure what's the meaning of the value of each one of these attributes here. So I feel like we kind of have to go from the index file that Git created itself. So what I'm thinking is that we can actually generate a very simple, the simplest index file that we can think about, and use this one to try to see if we can read from it and potentially encode the same value. Decode and encode this file to Scala case classes. So let's take a look at that. So I'm going to create a new directory here to actually generate the Git index file. So I'm going to call that test annex, and this repository, I'm going to get rid of this repository eventually. So I'm going to the text index and git init. Okay. So there should be the git. So you can see here that there is not yet any index file here. I'm gonna actually vim readme.md and write hello world, and save that. Let's see. So we obviously still don't have in the index here because we didn't run any comments since the readme was created. So I'm going to add readme. Now what we expect is that it's going to create the index file, because we said in the previous episode we mentioned this Stack Overflow that is referencing the article. We said that when we add, we create the index, and then that is used for commit. So going back to our IntelliJ, oh yes, now we have an index file. So now what I'm going to do, I'm going to go back up, and I'm going to copy this index file into the test resource, and I'm going to call this one index file simple one. We should have this file. Okay, we have this file here, and now, so instead of having this experiment, rename this file. I'm going to call that index file codecs spec. Okay. We're gonna rename this test path. So I'm not too sure exactly what should we. I'm gonna for the moment just decode, knowing that the test that I would like to do is eventually read the index file, decode it, and re-encode it, and see if it's actually the same than the file that I read. So Let's start by Decode, and then we'll probably change this test to have something a bit better. So we need to specify the test, the file that we copied. And the file that we copied is in src/test/3, so sys/index file, simple one. Okay, so he's gonna read this file, and so I kind of expect the code that we wrote last time. So you can see that here we are reading the headers and then the first entry. This code to work, and in this file we should have only one entry, I suspect. So let's try to run this. Okay, so we can see that we have the version 2 here, the number of entry 1, and it seems that these are the entries that we have. So I actually don't want to watch. Okay, so that's the good first point. What we didn't do here is decode the flags. So the flags, if I open the documentation here, so this documentation, happens to be not completely up to date. I found this documentation here that seems to be a bit better. And we can see that there are 16 bits flags that are composed of this. So the next thing that we're going to do is try to read these bytes, because the last bit of information, the last 12 bits of information to be more exact, give the length of the name field, because then we'll have to parse the name field. So it's going to be readme.md for us. So we're going to use this information here to be able to know how many bytes we have to actually parse. So to do that, we have a method that is called consume here. And consume is basically a function that is taking a codec, that is taking the result of the codec that we apply the function on, and returning another codec based off that. So I'm gonna call that consume, and you know what, I'm gonna accept this, even though I know it's quite incorrect, but I'm kind of hoping. Okay, trying to see everything here. So I activated soft wraps. So as you can see here that I have all what was parsed here. So actually I said that I don't want to have I don't want to parse U16 here, so I'm actually going to extract that into a variable that we can expand into the different flags. So I'm going to call that flags. Okay. And the flags are composed of this. Okay. The flags are composed of this. So the first is going to be assume value bool, extended bool, stage u2 int y not, except This probably doesn't work. So stage, I'm not too sure exactly what it is yet, so I'm just going to say bool bool to consume the 2 bits, 2 booleans for stage, and 12 bits for uint. The only thing is that uint 12 didn't exist. You have to provide the number directly as a parameter, I believe. Okay, so now we have flags. I think as well it might be time to actually start introducing some case class in here. So oops, for readability here, I'm just going to put them here, and we're going to refactor after, right? Case class flags. Flags, and it's going to be assume valid. Valid, which is boolean. Then we have extended stage. Okay, so a bit of help there from Copilot. Boolean. And the last one is name length, which is int. Very well. And I'm just going to map that. So if I just map here, it's going to give me back a decoder. But we are only working. So yeah, you can see here it's giving me back a decoder. But then it's not going to be compatible with combining that with the other codecs that we have here, because they are actually codecs. So what I'm going to do is I'm going to use xmap here and just implement the decoding part. Well, actually, yeah, just implement the decoding part. So Copilot is proposing that. Let's see what we have. I don't want to implement that for the moment. The second one is, I think, the encoding part. The first one is decoding part, if I'm not wrong. Oh no, the one is actually the first one is actually to transform from the tuple to the case class, and the second one is the opposite. So potentially it was correct, but let's see that later on. So we have the xmap here. So now we need to wrap that into parentheses, because otherwise it's not going to like that. Okay. There is another error. Ah, it's here, right? Let's just put not implemented for the moment. See if we compile. So apparently we. Okay, the consume is used here. Okay, so finally it's finished compiling. Now we have type issues. So it's saying that B is type variable with constraint tuple. So basically it was expecting tuple, but is not tuple. And the reason is that, okay, flat prepend here needs a tuple. Let me show you that. You can see here that the flat prepend is defined as an extension method, and the two generate type, there are two generate types here, A and B, and B needs to be a tuple here. B is basically the result of the function that is passed to flat prepend. And here we are starting to introduce the case classes, so that might be a problem. I'm just gonna explicitly define the types to make sure that we the compiler, to help the compiler a bit, and to make sure that the types are actually correct. The way I'm writing the code is actually correct. So here IntelliJ couldn't generate the type. I don't know if it's incorrect or just IntelliJ couldn't, so I'm just going to explicitly put that. So you see, instead of flat prepend here, I'm going to put consume for the moment. It's gonna kind of discard that, but eventually we will be able to get it back. So consume, let me see if we, let's see, what was the other error? Okay, header codec. Okay, let's continue and we'll fix that later. So now that we have our flags, we can use them to actually read the file path. So I'm gonna say that the next one is, so looking at the documentation here, it's called entry path name, so I'm gonna keep the same path name, and path name is gonna be so with scodec it seems that we are able to decode a variable number of bytes. We're using variable size byte, size bytes. Then we put provide for so we can either pass it directly or provide the value that we already know, and in this case we already know the value because we already passed it, and I'm going to provide flag.nameLength, I suppose I call that, and then it's going to be UTF-8 provide stops here though. Okay, and so I can consume that again, and so I'm going to have the path. And now I'm going to create a case class for representing the entry. Entry. Okay. So we have ctime, ctime second, same time, second, Dave, I know, mode, UID, GID, size, we have size indeed. The SHA-1 is an array of bytes here. Array of bytes, flags is flags, name is string. Perfect. So now we can go here and set, so name length is not correct. what did I put as the name is? Okay, I probably spelled it wrong. Okay, flags name length, and then we can actually instantiate the entry here. We see time sequence. Be good if I can get a suggestion from. Well, I can actually just come on, copy that, and put pass in the end, and that should be enough. Let's see what we have now. Okay, so we have the result of the compilation. So it still says that header codec is a recursive value, so I probably have another error. And SHA1 is a byte vector. Okay, so finally here we have a bit of progress. Now that I managed to align everything, so the problem is that we are using consume here that has two arguments codified, and xmap that have two arguments not codified. So in the same block of arguments, just to show you, xmap take f and g in the same block of arguments, and consume takes two functions in different blocks. So I somehow mixed that up. So now we have a result finally. We have an entry with the date, the SHA1 that is byte array for the moment, flags. Okay, and we can see that our size, the size of the path is 9, and we are able to get the file that we created earlier. So okay, so now that we have that, what's next? So I'm going to run that again to see how many bits are left. How many bytes are left? Okay, it seems that there is 168 bytes left. One thing that we discarded here is the headers. So I am actually going to try to see if we can keep the headers. So to keep the headers, where are the headers? The headers are here, okay. So do we have a flat... There was a flat zip, I think. There's a flat zip function that I might be able to keep the headers as well. Yeah, it seems to be similar to consume, but just take only one argument. Okay, so you can see that now we have also the headers. That is just a tuple for the moment. So we have version 2 and number of entry 1. So it sounds like we need to decode what's after the entries. And looking at the documentation here, so I'm going to scroll up here, and so the git index file has the following format: the headers. So that's what we already have. A number of sorted entries, okay, and extensions. Extensions are identified by signature. Optional extensions can be ignored if Git doesn't understand them, okay? Git currently supports cache trees and resolved on the undo extension. The 4-byte extension signature Okay. But just to take a step back, what we are trying to do is to write tree, implement something like write tree function in Git, which basically takes what's in the index file and create an object, write an object in the Git object repository with the current tree. And if we are able to read the file that we have, that might be enough. So to do that, we have a method that is called consume here. And consume is basically a function that is taking a codec, that is taking the result of the codec that we apply the function on, and returning another codec based off that. So I'm gonna call that consume, but what I'm thinking as well is that we kind of need a way to test that, and I'm not yet sure how to test that.